So in this case, we are going to consider a typical exam question, which is as a preparation for our exams as we are preparing for the tests that are ahead of time. You need to work as much question papers as you can, as you have done the introductions, each and every part of the term 3, and also remember term 2 and term 1. So this is Eastern Cape Province that we are going to consider, which was out of 75. So basically, guys, make sure that you go through the information and instructions that you are given. So we have got 3 questions that we are going to answer, and you must answer all of the questions. All right, make sure, guys, you read every part. Question number 1, we are given 1.1 in which quadrant, right? In which quadrant does the point 4 minus 3 lie? In which quadrant does the point minus 4 minus 3 lie? Where are we going to obtain that point? Remember, on a Cartesian plane, we have got the x-axis and also the y-axis. It helps us to locate a certain point by knowing the x value and the y value. So as we do understand, guys, x is positive this side and negative this side. Y is positive on top and negative down in terms of the values. So we can have the point minus 4, the x value being a negative, maybe somewhere there. The x being negative, the y being negative, maybe somewhere there. So we can see that the minus 4 and the minus 3 will meet at a certain point. Where they meet, that's the point. So this one is going this one is going this side. Where they meet, that's the point which is given there as minus 4, minus 3. So where is this point found? Which quadrant is this? The third quadrant. Remember, as you have got your quadrant, this is the first. All right, so we consider the first quadrant, the second quadrant, the third quadrant, the fourth quadrant in this direction. So where the point is, it is found in the what? In the third quadrant. All right, so the answer there was going to be the third quadrant. All right, let's consider another part of the question. We are given 1.2 to choose the correct word to correct the statement that we are given there. 1.21, if the gradients of 2 straight lines are equal, we've got 2 straight lines. They have same gradient. They are equal, same gradient. The lines are what? If the gradient is the same. All right, so this one, guys, it is straightforward from the properties of our straight lines. This is parallel. In order for us to have the same gradient, the lines, they're supposed to be what? Parallel. If 2 lines are perpendicular, 2 straight lines, if they are perpendicular, the product of their gradients is supposed to give us a -1. The product of their gradients. Like to say, if one gradient is m, the other one will be -1 over m. This is for perpendicular lines. But if they are parallel like this, they have got same gradient. All right, so we refer to this part. I just hope, guys, we are together. All right, then on 1.2, we are given that if the gradient of a line is negative, when a line is being drawn, wherever it is on a Cartesian plane or but it has a negative gradient. Remember, guys, I talked about this. These are the lines that do have a negative gradient. Then the line is said to be what? That's decreasing. Negative gradient, decreasing. If it is a positive gradient like this, positive gradient, that will be increasing. This type of a line which is going this way, going up like that. Those are decreasing. These ones, those are increasing. I mean, this part. But this one, it is decreasing. Negative, a decrease, positive, an increase. Then constant, when you're given something like this, it will be a constant. All right. So guys, like I said, just go through the introductions of the graphs. I talked about this part of the graphs. All right. Let us move on to 1.3. Write down the equation of a vertical line that cuts the x-axis at 2. If a vertical line is drawn, all right, remember a vertical line like this. That's a vertical line. So what is going to be its equation when it is drawn on a Cartesian plane? Passing through the point or passing through the x-axis at what? At 2. Remember the x values will be 0, going this side, 1, 2, 3, and so on. So when it cuts the x-axis at 2, it means it will be like this. It's supposed to cut the x-axis. This is our x-axis, this one. X-axis. So it's supposed to cut at 2, being vertical like this, being a vertical line. Write down the equation. What type of a line? What type of a line is that in terms of the equations? Remember the y-axis on its own, which cuts the x-axis at 0. Its equation is what? X is equal to 0. X is equal to 0. What about this one, which cuts the x-axis at 2? What will be its equation? A vertical line like this. X is equal to the value that it cuts there at 2. So x is equal to 2. So that's the vertical line that we are having there. Its equation will be x is equal to 2. Remember, guys, I told you all vertical lines like this, x is equal to a, where a is the what? The value that it crosses or it cuts the x-axis. If they are horizontal lines like these ones, y is equal to the value that it cuts the y-axis. If it cuts the y-axis at -2, it means that line will be y is equal to -2, a horizontal line like this, if it is a horizontal line. All right? Know your equations, guys, of the straight line, each and every type. Each and every type. All right? So there we said our answer is going to be x is equal to 2. 1.4, consider these 2 points. 1.41, calculate the gradient between the points. The gradient. Remember, when given 2 points, we can name the first point x1, y1. The second point x2, y2. So the gradient can be calculated. Remember, gradient, we can use the letter m to represent the gradient, or you can write gradient is equal to, all right? Or you can just use the letter m for gradient. So gradient, from our formula, guys, I told you the formula, the change in y over the change in x, y2 minus y1 over what? x2 minus x1. Yes, you can use y1 minus y2 over, you must start with x1 minus x2. You can also use this. It is one and the same. You're going to have the same answers there. All right, so that is it, guys. Let's substitute. What is the y2 according to the points? Y2 is what? Is 5. Minus y1, which is what? Minus 1. So the minus here is for the formula, but the y value that we are having here is what? A negative. So that's -1. Okay. Everything over what? X2, which is a 3, minus, as we have got on our formula, x1, which is what? Which is 1. So that is it. We can simplify this and obtain our gradient. You can use your calculator. You can add minus and minus here. That's a plus. So 5 plus 1 is going to be 6 over 3 minus 1, which is 2. So that was going to give us what? 3. So we have got a gradient of 3. So that's our m, which is what? The gradient. We can use, like the other formulas, still going to have the same answers there. Then 1.42, write down the equation now of the line through these points that we are given before. These points that were given before, remember from those points, we calculated their gradient here. So we already have the gradient of these points. Okay? If the y-intercept of the line is -4. If the y-intercept of the line is -4, when we are given the y-intercept, remember the equation of the line, y is equal to mx plus c, where m represents what? The gradient, and c is our y-intercept. So we can simply substitute what we are given. Y is equal to what? What is our gradient? M. The gradient that we calculated before is what? 3. So it's going to be 3. Then x as it is, plus the y-intercept. The c value is the y-intercept. You are given that the y-intercept is what? -4. So that's a -4 like this, all right? Remember, plus and minus is going to give us what? A minus. So 3x minus what? -4. That was going to be the equation of the line. Answer the question. All right? 1.5 we are given. Consider the flow diagram below. So they gave us the flow diagram. Remember, these are the inputs. We have got the equation here, which represent what? The rule and the output. That is what we are given there. So the question is, from this flow diagram that we have, or from this information, calculate or write down the values of A, B, and C. We must find the value of A, the value of B, and of C. How? Okay, so let's just analyze, guys, our flow diagram. That's for us to answer this question. We just have to analyze what we have: input, the rule, and what? Output. So the first part here, to find A, which is our output, what is its corresponding input? Because we know that y is equal to what? 4x minus 1, where the input are the x values, remember? The output are the y, they represent the y values. So when we input x, which is a 0 in this case, into this rule, the output is supposed to be what? It's supposed to be A, which is the y value. So it is just substituting the value of x. X, our input, is what? It's 0. Remember what we are starting with, input. So 4 times what? Times 0 minus 1. You substitute the input that corresponds to the output. So when you substitute this, you must obtain the y value. So 4 times 0, that's 0 minus 1. That's y is -1. So the y value is supposed to be what? -1, which is the corresponding here as the output. It is supposed to be a -1. That's the value of what? That's the value of A. So meaning to say our A is going to be what? A negative 1. Same concept. We move on to B. B is the input. Remember, input represents the X values. So B, if you input that B into this rule, we must obtain what? We must obtain a 0 like this. That is what we have. So meaning to say, we must find the X value that we inserted into this rule, so that our output is what? Is 0, because we are given there. Remember, output represents what? The Y value. So we are given the Y value, which is what? Which is a 0. It is equal to what? 4x minus. Suppose we do not have the X value. Our X value is what? Is B. B represents X value. So by finding that X value, we are determining the value of B. Remember your equations. Solve your equations. Take the -1 to the other side. That was going to be a positive. Remember, the moment it crosses the equal sign, it changes the sign. So that's 0 plus 1, which is 1, is equal to 4x. Right? So finding x, we have to divide this one by 4, since we've got a product here. So you have to divide in order for us to remain with x. So therefore, our x is what? 1/4. X representing what? The input value, which is what? Which is our B. So therefore, our B is equal to 1/4. The input. So that's the same thing that you're going to do to determine the value of what? Of C. It is the output from where? From this input of 1/2. We inserted this into this rule to obtain the value of C. Just like that. So you just have to substitute into the rule that we are given. What is it that we are given? We are given the X value, the input. We do not have the Y value. So Y is equal to, we substitute the X value 1/2, just like that. You can even use your calculator there. That's 4. You open the bracket, 1/2 like this. Close the bracket, then subtract a 1. That was going to give us a 1 at the end. So Y is equal to 1. So Y represents what? The output, which is the value of what? Of C. So therefore, C was going to give us a 1. So that is it. Just have to be straightforward into the given rule, understand the idea of that input and output, all right? A sketch of the line 2y plus x, 2y is equal to x plus 2 is shown, all right? So this is the sketch that we are given. And from this sketch that we have, 1.61, it was to determine the coordinates of the points A and B. The coordinates, finding the X value and the Y value. Knowing this, we have got a point. So what is it at A and B? This is our A and this is our B. So remember the concept that we do understand of the lines, the Cartesian plane. What is it that you know about that Cartesian plane, the x-axis and the y-axis? We know that in the x-axis, because A lies in the x-axis, so we must know the properties of that x-axis. Along the x-axis, we know that y is equal to 0. That's the equation. Along the y-axis, this y-axis that we are given, throughout that line, x is equal to 0. So that can simply help you to find the values that are at A, the point. So at A, because already we know something there at A, it lies where? In the x-axis, where y is equal to 0. So it just A there represents the x-intercept. It represents the x-intercept of the graph. Knowing that it represents the x-intercept, it follows that y is equal to 0. So when y is equal to 0, it is just like a point, guys. Remember, a point is made up of x followed by y. So you know that y is equal to 0. Remember that. So what is it that you must find? It is the x value that you need there. Where are you going to have that x value? By simply substituting into the equation. 2y is equal to what? X plus 2. When y is equal to 0, place it there in place of y. Solve for x. So it is like this, 2 times a 0 like this in place of y is equal to x plus 2. Then I can solve for x. All right. So 2 times 0, that's a 0, which is equal to x plus a 2. So to solve for x, we're going to take the 2 to the other side. The moment it crosses the equal sign, it changes the sign into a negative. So that's 0 minus 2, which is going to give us a negative 2. So that's negative 2 is equal to x. So the x value at a there is what? A negative 2. So that's a point, a being minus 2, 0. Remember, the y value is already given. So that's our point A in this case was going to be written as what? Negative 2, 0. You must know the x value and the y value. All right? And the point B can also be determined using the same concept. Where is it found? The point B lies where? In the y-axis, where I said x is equal to 0 there. So that's at point B, we simply understand that x is equal to 0. It is the y-intercept, this one. Remember that. This one, it is what? Our x-intercept. So when our x is equal to 0, substitute it in place of what? X there. Then solve for y. Since 2y is equal to x plus 2, but now in place of x, you put what? A 0 there. Because we said x is what? X is a 0. So it's just like at B, we have the x value, which is a 0. But we do not know the y value. So by substituting this 0 into x, we can solve for y. All right. So that's 0 plus 2, meaning to say y 2y is equal to 0 plus 2, which is 2. Divide by 2. That's a product there. So we must divide. So y is equal to what? To 1. That's the y value at B. Since x is equal to 0 there, the y value is what? Is a 1. So therefore, we have got a point, which is B is going to be 0, 1. Just like that. 1.62, it is hence or otherwise write down the gradient of the line AB. Hence or other, it is up to you. Are you going to continue using these 2 points to determine the gradients? That's the hence method, as we are given 2 points. Remember, I said you can have this as x1, y1. This will be x2, y2. Remember, guys, our formula for the gradient m is equal to y2 minus y1 over what? X2 minus x1. We were going to substitute the y value, which is 1, minus y1, which is a 0 there. Everything over what? X2, our x2, that's a 0, minus x1, as we can see, x1 is what? A negative 2. All right, so that was going to be a negative 2 like this. So you can simplify this 1 minus a 0, that's 1, minus a plus, so that's a 2 there. You are going to obtain a gradient of 1 over 2 from the points that you calculated here. Okay? Is it the only way that we could have determined the gradient between these 2 points? These 2 points, remember, they are taken from this equation. So we could have determined from the equation another way that we could have used from the equation. From the equation, we can determine the gradient. Even by analyzing the graph on its own graphical. But what about the equation, the one that we are used to? Remember, if the equation is written in the form of y is equal to mx plus c, m represents the gradient here. So thus, we simply need to rewrite our equation in this manner. In that manner, make y the subject of the formula. Since 2y is equal to x plus 2, let us make y the subject, because this one is not y, it is 2y. The coefficient of y, the number effect, is supposed to be 1. Y is equal to. So how do we get rid of that 2? We divide by that 2 each and every term. Each and every that you see. So that's 2 and 2 is going to cancel. So y is equal to x over 2. Remember, that simply means 1 over 2x. When it is written like that, it simply can be written as 1 over 2x. All right? Plus 2 over 2. This cancels and gives us a 1. So as we can see, from that format of y is equal to mx, m is the coefficient of x. That's the gradient. So what is the coefficient of x? The coefficient of x is 1 over 2. So therefore, our gradient is 1 over 2. The coefficient of x. So as you can see, it is the same answer that we obtained here. Anyway, guys, anyway, know your equations. Know your graphs, I mean. Revise as many questions as you can. You can be able to answer these questions in any way that you understand. All right? Anyways, let us check another question. 1.7, sketch the graph of the function, this one. All right? A sketch can be considered, guys. Just like here what we had on this part. That's a sketch of the line. You see, from this one, let's analyze from this one so that it will be easier for us to sketch the other one. This line that we see, it was made from point A and point B, then joining those two. Meaning to say, if I have the x-intercept and the y-intercept, it is enough for us to sketch a line. Just like here, it was a sketch, this one. Remember this, it was a sketch. So we want the same thing. Let's do the same thing. So in order for us to have this sketch on 1.7, we just need the x-intercept and the y-intercept. All right, 3x plus 6y minus 12 is equal to 0. That's our given function, a linear function. So what is the x-intercept? All right, so we're going to find the x-intercept. Remember, for the x-intercept, y is equal to what? To 0. So when y is equal to, substitute into the equation, then solve for x. It's an equation. So that's 3x plus 6 times the y value, which is what? Which is a 0 like that. All right, minus 12 is equal to 0. Then we can simply solve for x. All right, so 3x, 6 times 0, that's a 0. Then this one is just going to cancel out. We remain with what? A minus 12, that's equal to 0. So to solve for x, take the minus 12 to the other side of the equation. That was going to be a positive. The moment it crosses the equal sign, it changes this sign here. So that was going to be a positive 12. 3x. We need x, not 3x. So what are we going to do? Divide. That's a product. So we divide by what? By 3. Both sides of the equation. So 12 divided by 3 was going to give us what? A 4. So that's the x value, the x-intercept, where y is equal to 0. So the point will be like this, 4, 0. Remember, the point is made up of x and y. So y is 0, x is what? 4. X-intercept. You do the same thing for the what? For the y-intercept. The same concept. Y-intercept. For the y-intercept, we do understand that x will be what? X will be 0 there. So when x is equal to 0, substitute it. Find the y value. So that's 3 times the value of x, which is what? Which is a 0, right? So 3 times 0, okay? That's the x value plus 6y minus 12 is equal to 0. Everything remains as it is. As we can see, 3 times 0, guys, was going to give us a 0. So this one cancels. We remain with what? Positive 6y, which is 6y minus 12 is equal to 0. So 6y is equal to what? The minus 12 to the other side changes. It's going to be a positive 12. So 0 plus 12, that's a 12 divided by 6 by 6. So therefore, y was going to give us what? A 2. Meaning to say the point will be 0, 2. X value is 0, y is 2. With these two guys, we can sketch our graph by knowing the x-intercept and the y-intercept. We can sketch our function. What is important, guys, is to indicate, to show those two. Knowing this is your x-axis, this is your y-axis, we have got the 0 there. So where are we going to have the point, the x value 4? You just need a sketch, guys. 4 is positive on the positive side of x, on the right side of x. So we can just say this is where we've got our 4. Y is 2. Y is what? On top there. These are the positive values of what? Of y. So we can just sketch anyway, just mark any point. You can call it 2. So from these 2 points, a straight line can be drawn. They're enough, these 2, for us to have a straight line. They're enough. You just need to join the 2 points. All right. So in this case, it was going to be something like this. All right. Something like that. Passing through the points that you indicated before. The x-intercept, which is the x value at 4, and what? And the y-intercept. Those are the 2 points that are enough. These ones, they are enough for us to have a sketch. So this is what we have. We can even write down the equation as it was 3y plus 6y, 3x plus 6y as it was given. This is the equation. So it was given as 3x plus 6y minus 12 is equal to 0. There is no need for you to rearrange the equation of the line that we are given. Yes, you can do that if you want to have it in the form of y is equal to mx plus c. But knowing these guys is important. Knowing just x-intercept and y-intercept, those two, you can sketch any line with those two. By knowing this concept, we can sketch any line with this method. All right. 1.7, that's 1.8 now. Consider the equation of the line given by y is equal to mx plus c, which is, we are dealing with what? A linear function, okay? Consider that. Sketch the graph if m is greater than 0. What are they trying to say there? M is greater than 0. Remember, M represents the gradient. So they are saying the gradient must be greater than 0. That's values greater than 0 are referred to as what? As positive. So if the gradient is positive, a line is increasing, remember, like this. The steepness of the slope. Another part, we are given that C is less than 0. That's, we are talking about a negative there. But remember, C represents what? The y-intercept. So they are simply saying the line that we are going to have as our sketch, all right? The line that we are going to have as our sketch, it is going to cross the y-axis because it is given as less than 0. So it is going to cross the y-axis below this point here, below 0, here, below, like this. That's where we've got negative because we are saying it's less than 0. So the y-intercept can be found anywhere along this side in the negative. Remember, positive on top, negative down. So we can have the y-intercept anywhere. Let's say here, this is where we have our y-intercept in the negative region. But this line that we're talking about, we are told that it has a gradient which is positive, greater than 0. So I said increasing. So it means we have got an increasing function from that point where it cuts the y-axis at what? At a negative value. The function is increasing this way. So this is the sketch that we are going to have. That is the sketch that you're going to have. We are not given exact values, guys. They want you to understand your graphs. Deep down, understand each and every concept of the graphs. Not just the basics. Each and every concept, all right? So make sure that you do revise as many questions before you write your exams or the tests that you're going to write for your term 3. Question 2, 2.1, complete each of the following statements. 2.11, supplementary angles have a sum of what? Remember, supplementary angles are two angles which add up to 180 degrees. So a sum of 180 degrees. All right? 2.12, if two lines cut, a line and a line like this, they do cut, then the what angles are equal? What type of angles that are formed when two lines cut like this? Two straight lines. These are referred as what? Vertically opposite angles. And we do understand that they are equal. So here it is supposed to be what? The vertically opposite angles. Vertically opposite angles are equal. Vertically opposite angles. If this is 50, this must also be 50 degrees. All right. If this is 130 degrees, this is supposed to be 130 degrees, vertical opposite angles. Okay. So that was it. 2.2. Determine the value of the unknown variables in the following diagrams, giving reasons for your statements. 2.21. X. The variable that we see there is X. Where is it found? On a straight line, just like here, what I was explaining here on these two supplementary angles, which gives us what? 180 degrees. There are two angles which are on a straight line. By taking these two angles, the X and the 135 degrees, adding these two, we must get 180 degrees. Why? A straight line. I talk about a straight line, angles on a straight line. All right, so these are angles on a straight line. Okay, on a straight line. So let us solve for X. It's an equation now. We are back to our equations. Take 135 to the other side of the equation. The moment it crosses the equal sign, it changes the sign. So that will be a negative. Remember, it was a positive. So it changes to a negative. So that's minus 135. So subtract this from your calculator. You're going to get 45 degrees. All right. So that's our X value. Moving on to question 2.22. We are given two lines that are parallel in this case. There is this line. All right. So let's see. Right. Just gonna try and see here. So we are given this line, all right, parallel to this one, all right? So it's like this. Then we also have the transverse, the line which crosses the lines which are parallel, all right? So this one and this one being parallel. From where this indication, remember I told you, you do not assume that the lines are parallel. It's either you are told that they are parallel or you see by these symbols, this indication. It indicates that the two lines are what? Are parallel. Don't assume you see a line like this and a line like this, you say they are parallel. No. Unless you are told or you have got this indication. And the variables there, it was this x, there is this y here, and there is a z here. These are the variables, 3 of them. All right. So we need to find these variables. All right. So the question is, how are we going to determine these? Let us start with the x. X and 25 degrees here. There are two straight lines, this one and this one, which cuts. Remember we said when two lines, straight lines cuts here from this part, vertically opposite angles are what? Equal. And this is exactly what we are seeing between x and 25 degrees. Those are vertically opposite angles, these ones. So x is equal to what? X is equal to 25 degrees. Vertically opposite angles. All right, vertically opposite angles. I'm just going to write in short. All right, what about y? To find y, we can use the 25. Remember, this is 25 here. We now know that. So we can use angles on a straight line. X and y are on a straight line. Or 25 and y, still anyone here, any one of these, they're on a straight line. So y plus 25 degrees is equal to 180 degrees. Angles on a straight line, just like the previous question here, angles on a straight line. Remember, just same way, they do repeat this. So y plus 25 is equal to 180 degrees. Angles on a straight line. So let us solve for what? For y by taking the 25 degrees to the other side of the equation. So that was going to give us what? A negative. So that's 180 minus 25 degrees, which is going to give us 155 degrees. All right, 180. That's 180 minus 25 degrees like this, 155. All right. So we have got the y value there, 155 degrees. Okay. We are left with what? A z. So to find z, so many ways. All right. We can use the concept here. As we can see, we are forming z there, z angles, alternate angles where we form a z, alternate angles. So angle x and angle z, they are supposed to be what? Equal, where we form a z. So z is equal to angle x, alternate angles. So meaning to say z is equal to what? Our angle x is 25 degrees. We are talking of what? Alternate angles. To find z, we could z. There are so many ways, guys. We could have used this one, the ones that form a C, co-interior angles, if two lines are parallel. So it follows that y and z, when added together, they are supposed to give us what? 180 degrees. Y plus z is equal to 180 degrees. Co-interior angles. That's another way. That's another way that we could have used to calculate our z. So we simply have to substitute because we have got the y value. So y value, it was what? 155. So 155 degrees plus z is equal to 180. So z was going to be 180 minus 155 degrees. That's z is equal to 25 degrees. Okay? That's another way that you could have used to find the same Z here. Another way that we could have used to find the same Z, corresponding angles where we form F angles. Are we seeing the F like this here? These two lines are parallel. So corresponding angles, we are forming that F. If we check properly there, from this 25 degrees here and the Z, all right? Sorry for that. Like this. If you check properly there, there's an F. So the 25 degrees and the Z. So Z is directly equal to 25 degrees from where? Corresponding angles. F angles. Guys, it's in your hands. It's in your hands. To answer these questions, it's in your hands. Anyway, as long you have a reason for that statement, take note, they said, determine the value of the unknown variables. But whatever that you're going to be using to answer, giving reasons for your statements, as long there is a reason, you're good to go. All right. Anyways, let us see. 2.3. In the diagram, we are given the angle DEG, which is 90 degrees, represented by a right angle there. That's 90 degrees. Then D, E to F, which is 5x, and another angle from G to E to F, which is 3x plus what? 30 degrees. That is what we are given. Calculate stating reasons the size of angle GEF. GEF, this one. 3x plus 30 degrees. Find that angle. All right. What can we do, guys? What is it that we can do here? Remember, angles at a point, they add up to 360 degrees. So if I add everything that I'm having here, the 90 degrees, I add it to the 5x. I also add it to 3x plus 30 degrees. I'm supposed to obtain 360 degrees. Angles at a point. A complete revolution. Angles that are around a point. Okay, so let's solve for x. Remember, collecting our like terms, we have got here on the left-hand side, 90 to 30 degrees. You add these two, so 90 plus 30 is what? 120. So you're going to have 120 degrees. 5x and 3x was going to give us 8x, which is equal to 360 degrees. So to solve for x, we can take the 120 to the other side of the equation. So we're going to left with what? Positive 8x on the left-hand side, which is equal to 360 minus 120. We take this, it crosses the equal sign, it changes the sign. So 8x is equal to what? We are solving for x, guys, okay? That was going to give us 240 here. Then divide by 8 both sides. So x is equal to 30 degrees. We obtained the x value for us to determine the angle, which is given as what? GEF. Since it is given in terms of x, 3x plus 30 degrees, we must substitute the x value now into the given expression for the angle. So that's 3 times our x value, which is 30 degrees. Whatever that we are going to obtain, we must add the 30 as it is given there. So 3 times 30, that was going to be 90 degrees. Then 90 plus 30, which is 120. So that was going to give us 120 degrees at the end. So these are the questions, guys. Know your equations. Also revise your grade 8 equations, those algebraic expressions, and so on. 2.4, from this diagram that we are given, We are told that PQ is parallel to RS. PQ is parallel to RS. Okay, this is what we are given from these lines. Determine stating reasons the value of 2.41x. How can we determine the value of x if these two lines are parallel? Let's see where x is. X is here on angle SRT, this one. That's where we've got x, 2x plus 10. So the question is there any angle that we can relate to that x? Is there any way that we can relate? So I want you to see something, guys. If we check at angle P, because we've got these lines that are parallel, we are forming a Z like this. So angle P and this, you can see that those are alternate angles. So it simply means there's a relationship between this angle y plus 40 and 3y minus 20. That is what I'm trying to say. We have a relationship, but that one must have x. So is there a relationship for an x? If we check, there are f angles. Remember, corresponding angles, they are equal. We form an f here. If we check properly, that was going to give us f there, like this. So meaning to say the 50 degrees and the 2x plus 10 forming that f, this one and this one, they're supposed to be what? Equal. So we can form an equation from that. There must be x. So for x, 2x plus 10 degrees is equal to what? 50 degrees. Why? F angles, corresponding angles. All right, so you're talking of what? Corresponding angles. Since we are given these two lines that are parallel, since PQ is parallel to RS. So let's solve for x. 2x is equal to what? Take the positive 10 to the other side of the equation. That was going to give us a negative. The moment it crosses the equal sign, it changes the sign, remember? So 50 minus 10, that's 40 degrees. To find x, simply divide by 2. So that's our x was going to be what? 20 degrees, okay? So we have got the x value in case that we want to substitute that x value. Okay, let's see another part of the question. 2.42, the y value, all right? So to find the y value, remember this one, I have already stated it before when I was mentioning about the alternate angles, remember? Here, Z angles. We are forming a Z there. We are forming a Z. So to find the y value, we simply have to equate the angle at P, which is y plus 40 degrees, as it is to what? The angle at R, this one as it is 3y minus 20 degrees, where we form a Z. Z angles, alternate angles. So we are talking of what? The alternate angles. So solve for y there. It is in your hands, guys. You can collect the like terms. Minus 20 to the other side of the equation was going to be a positive. So we have got positive 40 there. So that's 40 plus 20, which is equal to, we take y to the other side. So that was going to be a negative. So it's 3y minus y. Okay, let's add 40 plus 20. That's 60 degrees. 2y minus y is just like 1 there. So 3 minus 1, that's 2. All right. So if 2y is equal to 60 degrees, what about the value of y divided by what? By 2. So that's our y value is equal to what? 60 divided by 2, that's 30 degrees. All right. So y is equal to 30 degrees. That is what we are given. Just like that. On 2.5, we are given this diagram. In the diagram below, prove stating reasons that AB is parallel to CD. AB is parallel to CD, but they said prove. You are not told that they are parallel, guys. No, no. When we are told that these lines are parallel, we just say, okay, this one is, no. To prove, you must use any concept that you know about parallel lines because you're told that they are parallel. So use any concept, any mathematical concept about what? Parallel lines. As long it is valid, therefore these two lines will be what? Will be parallel. So what can we do? There are no angles that we can relate it to. The angle of 165 and this angle of 65 degrees, they do not have a relationship. This one is outside, this one is outside. All right? But we do understand that if truly that AB is parallel to CD, if we are still assuming that they are parallel, if truly that they are parallel, these two lines, one, the angle of 115 degrees must be equal to x. That is what we know. The angle of 115 degrees, this one, must be equal to x, where we form what? F angles. Look at the F there. So this one is inside, the other one is outside. Corresponding angles. So if truly these two lines are parallel, angle x must be equal to 115. So can we prove that? Prove that x is equal to 115 degrees because we know that if these two, there is no way the lines will be parallel because they will be called what? Corresponding angles where we form an F. So let's find x first. How can we find that x? Because we are not told that they are parallel. So we must use any other way to find x. There is a straight line. Angles on a straight line add up to 180 degrees. So find x first. So x plus 65 degrees is equal to what? 180 degrees. Angles on a straight line. On a straight line. All right. So from that, we can solve for x by taking the 65 to the other side becomes a negative. So 180 minus 65 degrees, that's x is equal to 115 degrees. Guys, there is no way that this angle is 115 degrees. Then here also, it is also 150. Here, there is no way, guys. It simply means these two lines, they are parallel. The F angle concept is what? Is confirmed. The F angle concept is what? Is confirmed. So therefore, AB is parallel to what? To CD. There is no way here. There is no way. Because of what? We know corresponding angles. We are talking of what? Corresponding angles. The ones that form an F. They're equal. So these two, for them to be equal, automatically it tells us that the lines are parallel. It's an automatic answer that. All right. 3.1, complete the following statements. That's 3.11. The sum of interior angles in a triangle is what? That is 180 degrees. And 3.12, a triangle with all sides and all angles equal is referred to as what? That's an equilateral triangle, that one. All right. Then the sum of angles in a quadrilateral is 360 degrees. All right. There you just need to know your properties. 3.12, the opposite of a parallelogram are equal and parallel. Those are what? Sides. Remember, the opposite sides of a parallelogram are parallel and equal. So these are opposite what? Sides, not angles. You cannot say angles are parallel, guys, like this. These are opposite angles, just they're equal, but not to say angles are parallel. All right. We talk of parallel sides. So those are opposite sides that we are talking about. All right. Another statement on question 3.2 was to determine the value of the unknown variables in the following diagrams, giving reasons for your statements. 3.21. This is our diagram for 4 marks. Our variable being what? X. How can we calculate X? There is only one angle that you are given. If we were given this angle, we're going to use the concept of what? Angles in a triangle. Remember, we just mentioned that sum of interior angles in a triangle, they add up to 108. We do know that these angles inside, they do add up to 108, but there is no angle C. If there was angle C, at least we can just add everything, then subtract from 180. So the question is, where can we have the angle that is at C? Remember, from these two lines that we are given, AB, which is equal to AC, it follows that these angles that are opposite these lines, these angles that are opposite these lines, they are equal. Angle B is equal to angle C. So meaning to say, angle C is what? 50 degrees. Which concept is telling that angle B is equal to angle C? We are talking of what? Angles opposite equal sides. All right, remember that. From an isosceles triangle. So that's basically angle C is what? 50 degrees. So if angle C is 50 degrees, therefore angle X can be calculated, because if I add angle X to the 50 degrees at B and the 50 degrees at C, I'm supposed to obtain what? 180 degrees. From which concept? These are angles inside a triangle, co-interior angles, sum of angles in a triangle. Just like that. So meaning to say that we can solve for X. All right. So let's add our angles. 50 plus 50, that's 100, which is equal to 180 degrees. So to solve for X, we can transpose, take the 100 to the other side. That's 180 minus 100, which was going to give us what? 80 degrees. So X is equal to 80 degrees, just like that. As long there is a statement, there must be a reason to support that from your properties of the given shapes. Parallel lines, everything. 3.22, we are given a triangle and it is extended to GA, that's the variable being X. How can we solve for X? What is it that we know from a triangle of that nature, where there is an exterior angle? We do understand that this exterior angle that we see is simply the sum of the two opposite interior angles. Two opposite. This is the interior angle at E, but opposite, the interior opposite. So that's 3x is equal to the sum of these two, x and what? 66 degrees. We have formed an equation. From that statement, we are simply saying the exterior, remember that exterior angle equal to sum of what? Equal to sum of opposite interior angles. So thus we can solve for x. Take this one to the other side. That's what's going to be a negative. So 3x minus x is equal to 66 degrees. This is same as 1. So 3 minus 1, which is what? 2. So 2x is equal to 66 degrees. Divide by 2 by 2. So x was going to be 33 degrees, just like that. Know the properties of what? Your triangle, guys. If there is an exterior angle, it is equal to the sum of the two opposite interior. Two opposite. If I add these two opposite, it must give us the exterior angle. On 3.3, we are given in the fig below, A, B, C, D is a what? A parallelogram. They told you that. Remember your properties of a parallelogram. Opposite sides are parallel and equal. Opposite angles are equal. The adjacent angles add up to 180 degrees. Know all the properties, guys. So they gave us AB is equal to, from this one, AB, it is equal to AE, all right? So meaning to say from that concept, we're going to have the angle at X being the same as angle B1. Remember the concept of the angles which are opposed to what? Equal sides. Then we are given that angle AEB is X and angle D is 3X minus, this angle D is 3X minus 20 degrees. Okay, that is from the diagram. This is what we are given. So determine with reasons 3.31 two angles that are equal to X. There are two angles there which are equal to X. Already I have stated here the first one, which is what? Which is angle B1. So that's 3.31 angles which are equal to X. Angle B1 is equal to angle X. Why are we saying that angle B1 is equal to X? We are talking about what? Angles which are what? Angles opposite equal sides. So this is, all right, angles opposite, angles opposite equal sides. So we saw that from the side that we're given. So that's the B1 there is X. B2 is also equal to X. Are we seeing that we are forming a Z, the alternate angles from the what? Parallel lines, since BC is parallel to AD. We are forming a Z there, B2 and that X. So that's angle B2 is also equal to X. Alternate angles, where we form a Z angles, they are equal. So those are the two angles that we have which are equivalent, to X, okay? There is any other one, let us know, guys, from the comment section. All right, 3.32, hence or otherwise calculate the size of X. Are we going to use those two angles? If there is any other way, but they said hence or otherwise. Remember angle B1 and angle B2, they are equal, and that's equal to X. So meaning say the whole of angle B, is equal to what? X plus X, which is 2X. Because B is the sum of angle B1 plus angle B2. So that's angle 2X. But remember, we are dealing with a parallelogram. Properties tells us that opposite angles are equal. The angle at B is the same as the angle at D from the properties of what? A parallelogram. In a parallelogram, opposite angles of what? A parallelogram. Remember, they are equal. So that's the angle at B, X plus X, which is 2X, must be equal to the angle that is at D, 3X minus what? 30 degrees, as it is. That's 3X minus 20. 3X minus 20, I mean 3X minus 20 degrees. Solve for X. It's an equation. So you can even take the 3X to the other side. It becomes a minus 2x minus 3x is equal to what? We are left with a negative there. So to find x, 2 minus 3, that's minus x, minus 1x, which is equal to negative 20. So negative cancels. So therefore, x is equal to what? 20 degrees. Just like that. Just like that. And on the other section, we are given 3.4. In the diagram below, there are angles that are given. The angle that is at C, angle CBD, which is 50 degrees, the angle which is at E, which is X, and also angle B1 is equal to angle B2. These two, they are equal. D1 and D2, they are also equal. So from that, the question is determine with reasons the size of X. 8 marks. Size of X. Determine with reasons. We are told, guys, angle D1 is equal to angle D2. Angle B1 is equal to angle B2. What can we do to find X? Look where X is. In an isolated triangle where there is no angle inside. So it means we must use every knowledge that we have to find this angle inside the triangle, angle B2 and angle D1. How is that so? Let's try to fill in the triangle at least, all right? Let's start with the B2 because there's something about B1 and B2 there, all right? Remember, we are given that B1 is equal to B2. But if we add everything there, B1 plus angle B2 plus 50 degrees, we must get 180 degrees angles on a straight line. On a straight line, all right? Just gonna write in short, guys. Angles on a straight line, all right? Just in short. So meaning to say we can have the B. Because B1 and B2, they're the same. You're given that B1, angle B1 is equal to angle B2 given. So meaning to say I can write either B2 as B1 or whatever that I want. B1 as B2. But as we are focused with what? B2, the one that is inside of the triangle. So in place of B1 there, I'm going to write it as B2. So it's B2 plus B2, which is going to be what? 2B2. All right? Plus the 50 degrees is equal to 180 degrees. So solve for that angle B2. All right? Take the 50 to the other side, that 180 minus 50, which is 130 degrees. All right? Solve for angle B, divide by 2 by 2. So that's our angle B2 is equal to what? That's divide, it was going to be 65. That's our angle B2. Remember, B2 and B1 are the same. So if here there's a 65 degrees, it means also there's a 65 degrees at angle B1. All right? So at least there's an angle inside the triangle so far. We've got one angle so far. We've got one angle inside this triangle. Remember, we need two angles because we know angles in a triangle, they add up to 180 degrees. So at least we must have the angle at D. D1. How can we have that angle? All right, let's start in triangle CBD, this triangle. Find angle D3. So in triangle CBD, let us find angle D3. All right, if I add the 70 degrees plus the 50 degrees at B plus the angle D3, we must obtain 180 degrees inside this triangle. Angles in a what? Angles in a triangle. Okay. So 50 plus, 70 plus 50, which is subtracted from 180 in order for us to have angle D3. That was going to be, this one is going to give us 120. We take the 120 to the other side. So that's 180 minus 120, which is what? 60 degrees. So angle D3 is 60 degrees, this one. That's our angle D3. So are we seeing that to find the angle D1 and angle D2, we are going to use same concept as we used here to find angle B1 and B2. It is the same thing because we are told that they are equal. So we are going back to that concept that the angle D1 plus the angle D2 plus the 60 degrees must give us what? 180 degrees. We find angle D1. We are focused with the angle inside the triangle. By finding this, you're done. Angles angles on a straight line. So this one is about angles on a straight line. All right. So D1 and D2, remember they're equal. We are given that D1 is equal to angle D2, given. So thus I can write angle D2 as D1 or angle D1 as what? As D2. As we are focused on angle D1. So that's 2 angle D1 plus 60 degrees because it's going to be angle D1 plus angle D1. Okay? So that is equal to 180 degrees. Let us solve for that angle D by taking the 60 to the other side is going to be a negative. So that's 180 minus 60, which is 120 degrees. So that's 2 angle D1 is equal to 120 degrees. Okay? So divide by 2 by 2. Our angle D1 was going to be 60 degrees. So that's angle D1 is 60, angle D2 is 60. So this is 60 degrees. This is also 60 degrees. They are equal, all of these. All right? By having angle D1, it is easier now for us to determine the value of X. So all these calculations, you must have all these calculations. After that, find X. How can we have X now? Angles inside a triangle. So triangle BED or BDE, whatever way that you're going to name it, find X. All right. Angles in a triangle, remember, they add up to 180. So the 65 degrees plus the 60 degrees at D1 plus the X degrees at E must give us 180 degrees. We are talking about angles in a triangle. So that's so for X. 65 and 60 was going to give us 125. Okay, so that's 125 degrees plus X, which is equal to 180. So for X, taking the 125 to the other side, that was going to be a negative. So 180 minus 125, that's 55 degrees. All right. So that is it. So these are the typical questions that you'll be given in your preparations for your term 3. Those are the typical questions, how they can be like. All right. So do revise as many questions as you can. Revise as many questions as you can as you are preparing yourselves for the exams that are ahead of time. Make sure you know the introductions. Go through each and every topic. I have already listed that part. If there is any other part which is not yet complete, if you check the playlist, then you see there's a certain section which is not complete in that term that you are dealing with. Let me know so that we can add up everything. Prepare yourselves for the exams that are ahead of time.